Hi girls, I hope your day is going well. I did have a query from somebody about the question on torque and acceleration. This is question number 5, and it's only the last part that they needed clarification, so I thought I'd make a short video explaining this. So this is the scenario. So I'm drawing it all out. So there's your wheel and your axle, and there's actually two chords. So there's block A over here and there's block B there. So when block A accelerates downwards, block B is actually going upwards. Okay, it's accelerating upwards. So that's a scenario, and I'll just take you briefly through one little part. So if we are looking just at block A, because it's accelerating downwards, the forces are unbalanced, and so your tension force is smaller than the force of gravity, and so the unbalanced force acts downwards, causing it to accelerate down. And so the way we get your unbalanced force is the difference between the two, because gravity is bigger, so it's Fg minus Ft, and the unbalanced force is Ma is equal to that. And or if you make, we had to calculate tension force in an earlier part. So in order to get the tension force, you bring your tension force this side, so it becomes positive. Your Fg, which is mg, is already here, and you bring the Ma across to that side, so it becomes minus Ma. And so m is a common factor, so Ft becomes m times g minus A, and you substitute. You know the mass is 25 kilograms, and so times g is 9.81. Acceleration downwards is 2 meters per second squared, and so when you put all that, you get the answer to Ft, and that is for block A. Now the question was mainly about block B, but I wanted you to get this concept right before I went on to the next part. So, okay, so this is your block B, and just look at the forces acting on block B. Because it's accelerating upwards, so the forces are again not the same, and the only two forces acting on it are force of gravity downwards and your tension force acting upwards. But because it's accelerating upwards, your tension force is going to be larger than your gravity force. So your unbalanced force is Ft minus Fg, and looking at it exactly like how we did for block A, the unbalanced force is Ma, which is Ft, which is your larger force now, minus mg. So if you make Ft the subject of the formula, and I'm doing that because we need to find the mass m of block B, so I want to get the variables with m on one side of the equation. So your Ft equals, so the Ma is already here. Okay, it's got kind of rubbed out, and you bring your mg, which was minus mg here. When it comes to this side, you add them both, and then you substitute. Your Ft in an earlier part of the thing came out to 326.4 newtons, and that's equal to m times 9.81 plus m times 1, because we worked out the acceleration upwards was 1 meter per second squared. And so you just work through. So your 326.4 equals m is your common factor, and you add both these, and when you get m as the subject of the formula, you end up with 30 newtons as your 30 kilograms as your mass for B. I hope that makes it clear, and let me know if you have any more such queries. I'm happy to do a short video and explain it all to you. But great work, just keep at it. So just do a little bit each day, and then we'll get there. Okay, so bye and have a nice day.